Okay, now that we've done right Riemann sums, we can move on and do left Riemann sums. And again, if you understood the right Riemann sums, then you're going to get this perfectly because it's not that different. Instead, when we are using a left Riemann sum, then the top left vertice of each rectangle hits the graph. And remember, we're drawing these rectangles underneath the graph to give us an under or over estimate of the area of the graph. You know, it's a good way to give us a little approximation, right? So let's do a left Riemann sum to find the area under the graph x squared, right, from 0 to 3, right? So our first left vertex is going to be right here at x equals 0, and it's just going to give us a line, kind of like when we did a right Riemann sum for the graph on the right in the last video. So now our next rectangle is going to be at x equals 1, right? Left vertex hits the graph, and then we draw a rectangle. And then our last rectangle is at x equals 2. Left vertex hits the graph, and we draw a rectangle. Remember at the end of last video when I said, oh, you should remember that for right Riemann sums, when we have an increasing slope, we get an overestimate, and for decreasing slopes, we get an underestimate, and that this would change when we do left Riemann sums? Well, here you can see that we're doing a left Riemann sum on an interval where the slope is increasing, and we're getting an underestimate. Remember, see, we have all this dead space here that we're not calculating, so we're going to end up with an underestimate. Now, we know that the widths of all these rectangles are just one unit, and then we can find our height by plugging each of our x values into our y equals x squared equation. So y at 0 is going to be equal to 0. Y at 1 is going to be equal to 1, y equals 1 squared. And then y at 2 is going to be equal to 4. So we have, these are all of the lengths of our rectangles, and we had our widths, they're all equal to 1, right? So now we can find the areas of these rectangles and add them together. So length times width, plus length times width, plus length times width, right? So our first rectangle, which I shouldn't even call a rectangle, it's literally just a line, has width 1, length 0, plus our second rectangle, which is width 1 and length 1, plus our third rectangle, which is width 1 times length 4, and we add these all together. So 0 plus 1 plus 4, guess what? That's equal to 5, right? Now we're going to do a left Riemann sum to find the area under this function y equals x squared from -3 to 0, right? Left Riemann sum means we're using the top left vertex of the rectangle. Don't forget that, right? We're doing 3 even subdivisions, so we're going to have 3 rectangles. Our first one is going to be at -3. Now, hopefully you caught on to what we're doing here, so I can just talk while I draw these rectangles. Not every single time you do a left or right Riemann sum are you going to be asked to split it into equal intervals, right? You can do them as like skinny rectangles. Here, I'll draw a little thing. You can have a little skinny rectangle right here, and then one super wide one, and then another skinny one right here. That's still a valid Riemann sum, right? I'm just choosing to do the equal ones because I want to, because they're nicer, right? And when you're given a problem including Riemann sums, you're going to be told how many subdivisions you should have, whether they're equal or not. I, for the sake of being simple and introducing this topic, am doing these 3 intervals, 3 subdivisions on, equal length. So I just want to put that out there. If you have a question, it's not always going to be 3 rectangles that you're drawing. You'll be told how many subdivisions you need. Alright, well, since we've drawn our subdivisions, our rectangles now, we can find their lengths. And again, this might seem a little simple to you, but for others, who aren't catching on yet, we're going to do this. So our x values are -1, -2, and -3, so we can find all our heights. So y at -1 is going to be equal to -1 squared, which is 1. Y at -2, if you square that, you're going to get 4. And y at -3, when we square that, is going to be equal to 9. So we have the dimensions of all our rectangles, right? Width 1 times length 1 plus width 1 times length 4 plus width 1 times length 9. 1 plus 4 plus 9, and we get 5 plus 9 is equal to 14. Just like last video, except this time they're swapped, right? Remember when we did the right Riemann sum on the interval 0 to 3, we got 14, and when we did it from -3 to 0, we got 5, right? So this is how we do left Riemann sums, right? You could choose which one you want to do. If you want an overestimate or an underestimate, or you could just not choose at all. You'll get a problem saying, I want you to have 4 even subdivisions doing a left Riemann sum to find the area under this curve. Whatever you're doing, I hope that this video helped you understand the concept a little better. Thank you for watching, and I hope you learned something.